Hello and welcome. This is a continuation of the set and interval notation lesson, but this time we're looking at numbers presented on the number line. That's a graphical presentation, and we will have to describe them in both set and interval notation. So let's get started. In the first example, we have the numbers 0, 1, 2, and 3 marked on the number line. When this is the case, we call them discrete values of x or specific values of x. And an easy way to describe this set of numbers in set notation would be by simply listing the numbers from lowest to highest, separated by a comma and inside the braces. A fancier way of describing this set of numbers is by describing them as numbers that belong to the smallest set of numbers that they can fit in. In this case, we're going to say the set of whole numbers. So we're going to write x belongs to the set of whole numbers such that, and then we're going to list on the left side number 0, on the right side number 3, so the lowest and the highest. And we're going to say that x is bigger than or equal to 0, less than or equal to 3. So we're going to say that all the numbers must be between 0 and 3 with 0 and 3 included, and they must only be whole numbers, so not just any real numbers, so no numbers in between. When it comes to interval notation, it's difficult to describe this set of numbers because they do not make an actual interval. So we are going to skip this on this part. Let's take a look at the next example. We have the numbers starting from 2, increasing to infinity. So in this case, because the line is solid, we're going to say that x is any real number such that 2 is the only specific number we are given there. So we're going to say x is bigger than 2. It's not equal to 2. In the interval notation, we are going to say that x belongs to the interval from 2 to infinity. Remember that when the number is not included in the interval, we use round brackets, and around infinity, we always use round brackets just for the fact that infinity is not really a definite number, but infinity is actually a concept, so it's not a specific number. Now, in the next example, example C, we have actually two intervals. We can describe these two intervals in one set notation, and we are going to say that x is any real number. And the reason why we say is any real number is because we have a solid line in here, or a solid interval. And we're going to say that x is bigger than positive 3 and less than negative 3. So I usually like to use the same order. So I'll write negative 3 on the left and positive 3 on the right. I'll put x in between. Now, since x is less than negative 3, then we'll go this way. And since you see that the dot is filled in here, then we're going to say less than or equal to negative 3. And then about the next interval, so for the next interval, we're going to say that is a bigger than 3, and 3 is not included, so x is bigger than 3. Now, when it comes to interval notation, this will be an interesting way of presenting them because we have two intervals. So we start by writing again x belongs to, and we're going to write the first interval. Always write from left to right, so have an order, negative infinity, negative 3. And since negative 3 is included, then we're going to use the square brackets around it. And then we also have another interval we need to include here, which starts at 3 and continues to infinity. Now, the number 3, as indicated here by an empty dot, is not included in the interval, so round brackets, and infinity always has round brackets as well. Now there is something that we need to add in this interval notation. What we have to do is this symbol. When we have two or more intervals in a set, what we do is we use the symbol, which is like letter U. It stands for the word united, or you can look at it as a plus sign in math. So these two intervals are joined together to make the same set of numbers as described on this single number line. In the next example, we have example D, the numbers from -3 to +3. So we're going to say that x is any real number. That's because you have the solid line there, such that -3 is the lowest and +3 is the highest. X is in between. And x is bigger than or equal to -3, because it's to the right of it, and less than or equal to 3. When it comes to interval notation, we're going to say that x belongs to the interval between -3, 3. And now we have to think of the brackets. Since we have filled dots on both ends, we're going to say that we need square brackets on both ends. And we're done with this. In the next example, we are going to describe it in set notation as any real number x, such that now you see that all the number lines, all the numbers are included on the number line except for 1. So that would be -1. So we can simply describe this as x different than -1. So we are including all the real numbers except for -1. In interval notation, we're going to use the same format as in example C. And we are going to write that x belongs to the interval -∞, -1, round brackets, and then -1 to infinity. And again, round brackets. And again, don't forget one last thing, the join symbol. In the last example, we have the numbers between -3 and +2. None of the endpoints are included. So in set notation, we'll say x is any real number. The lowest is -3, the highest +2. Brackets, braces actually. And x is in between. We're going to say bigger than -3 and less than 2. In interval notation, we're going to say that the numbers are between -3 and -2. Always write them in order from lowest to highest. It's not optional. And round brackets around both -3 and -2 because they are not included in our set. So that was it for today, and I hope you found this helpful, and see you next time.